while back we made a YouTube video on how we were building this glycol chiller out of a Pioneer Minisplit, and it's been in operation here for probably about 6 months at least. It's been working really good. Today we made a small modification to it and had a viewer call in and ask us to do a little documentation on the actual controls of it. So I'll run you through what we got. We got basic Pioneer Minisplit 14 SEER analog non-inverter mini split. Output of the refrigerant goes up through a sight glass so we can check our fill. Goes to a internally equalized TXV. Refrigerant goes in here to a coil, then out through, and that's the sensing bulb, and then back to our compressor. Lift that up there. So you can see here's our coil. There is a small, very small fountain pump at the very bottom. You can kind of see a little bit of rippling in the glycol, and that's from the fountain pump. It's just a small bit of recirculation. That's all it is. It's just to keep the temperature kind of even. You got a couple wires coming down here. This is 120 volts for the submersible pump. This is an NTC sensor, so we actually know our temperature of our glycol. This is our supply. This is our return for our glycol. And what we did today was we installed this little knob which just controls the speed of this fan. So when it gets a call for cooling, turns on, this fan is full bore. For low temperature applications you don't need it full bore, so I went ahead and slowed that down. This little controller. So we got power coming in, goes to the GFCI first. So everything is GFCI protected, including the compressor. You're dealing with liquids and electricity. It's just best to be safe than sorry. This is our pump instead of our glycol reservoir, and then this is the power for the recirculation pump, which is housed inside that Cantex enclosure. The controller they're using is an Inkbird ITC 1000F. They are cheap. They're like 15-20 bucks. This is a 110 volt system. 110 in. You got your sensor, or your NTC sensor, which dives out the front here, goes to our glycol, and then this is our switch. When it gets too hot, it goes to cooling circuit, and you can see right there, it's just a relay. You don't have to follow this. You can put 12 volts through there, it doesn't matter. These aren't connected. This is just a typical hookup diagram. So when this gives a call for cooling, the first thing that it's going to do is it powers both of these. Delay on make, their universal timer by Mars 32391. One is set for 1 minute and the other one is set for, it looks like, 45 seconds or so. So that one's for the reversing valve and the compressor, and that one's for the condenser fan. So when this is timing, there's a potential across this because it's not connected. And when there's a potential across this, that potential energizes that little ice cube relay in there. And when it energizes, the first thing it does is there's a reversing valve. There you go. And that's going to equalize your high side and low side, just to ensure that the compressor will have a soft start and it's not going to be, deadhead the pump or something like that. Because if you run the compressor, you shut it off, and you try and immediately call again, you're going to be backed up and it won't start, and you damage the compressor that way. So by having that reversing valve activate, it'll equalize the two sides just for a bit. Now down there, there's the little controller I installed just for the fan. I want to see, can't really see down there. There is a little orifice tube and a check valve that sits way down at the bottom of this unit, and that was removed. That was one of the major modifications to the mini split. And when I removed that tap, or that check valve and orifice tube, I also installed a high side service port, which is right down there. So you pop the front cover and you can access that. Because when you're going to fill this, you're going to fill it not based on weight, but based on, you know, subcooling of the refrigerant. Because this is a TXV application now and not an orifice tube. And so, you know, I got mine to 8 degrees subcooling, and that seems to be plenty fine. Works great. I got a low temperature Emerson, you know, TXV over there. And so that seems to do the job just fine. Now, when this is timing, there's a voltage potential across this, which, you know, activates this relay and shuttles the reversing valve. When the timer has elapsed and it's done, this connects together, which gets rid of this potential. There's no potential between them because they're physically connected, which turns off the relay, shuttles the reversing valve back to the cooling position, and when this closes, it also turns on the compressor relay, which is right here. And so that the compressor starts, this is in cooling, refrigerant flowing in the right direction, and you've ensured that the compressor is not, you know, starting under a load. After about 15 seconds of compressor runtime, this turns on and activates your condenser fan. I feel like it didn't need to turn on right away. There's no use for it. It's just wasted energy. So that's the only reason for this, because it cycles so many times throughout the day. I was like, you know, it's a couple watts, it's a penny a day, you know, it's worth it. And that's basically all the controls. It's pretty straightforward to it. Every mini split's going to be different out there, but you just kind of have to follow the wires and see where they go, and kind of map out what it needs to do. I'm going to get this together here, and I'll show you what it sounds like when it operates. Here's our glycol pump just kicked on there. Hear that cycling. So we're at 23.1 right now. We're just gonna run this down so you can hear it. I'm just gonna set it to 10. Okay. So what you just heard was that switch, or that solenoid kicking on, which activates that reversing valve. And our sight glass is now empty. You heard a little squeal, that was just refrigerant flowing. So the next step in the process is it's going to do the solenoid the other direction, the reversing valve, and then kick on the compressor. And that should be here momentarily. There you go. And now in about 15 seconds, that fan's gonna kick on there. There you go. So that's your condenser fan. Now this little guy right here, this is a $7 AC Pwm module from Amazon. The thing is great. You turn this up, fan goes faster. You turn it down, the fan goes slower. Simple as that. And so I just took the fan input there, you know, from L1, you know, that's neutral, and then orange is your capacitor, so you don't want to mess with those. You're just going to put your PWM, on your input to your fan. And you know, like these use 4 pins there on the module. You know, the left 2 are in, the right 2 are out, but the outer 2 are just connected and they're not needed for the circuit to operate. So you can just omit those completely if you want. And I found that actually works fine on other AC voltages as low as 24 volts. So it's kind of interesting. So of course, if this fan runs too slow, it won't get proper subcooling. So you gotta make sure that your refrigerant that's coming out isn't hot. You know, it can be slightly warm, but you don't want it cooking. That would be not very good. Now, in the event that you had a power failure or a brownout, and then the power came immediately back on, you heard that power went out for a second, went back on, it got a call for cooling instantly. The compressor was under full load, so it switched this valve first, depressurized the system, everything equalized. Now it's done equalizing, it's done, it's that fast. Compressor kicks back on, it's not under load, easy startup. In another 15 seconds, we're gonna get our condenser fan kicking back on, and we haven't skipped a beat. We haven't waited long at all, and everything's up and running again, and we're cooling. So, yeah, there you go. There's kind of the basics of the controls for this Minisplit Glycol chiller. Everything's 110 volt from the reversing valve to the condenser fan motor to the compressor. 100% 110 relay logic controlled. There's no inverters, no computers, anything like that, and that makes it really easy to adapt a different control to this. And in the future, this will probably be PLC controlled, and this will probably go away, and it'll be integrated into a complete one complete setup. So if you guys have any more questions, feel free to reach out. Talk to you later.